Hello friends. In last lecture, we cover the Clausius inequality. Now, in this lecture, we try to focus on one question. So here, try to understand this question. So before this question, I want to repeat this. There is a Clausius inequality. The Clausius inequality say that if there is a cyclic integral of del q by t less than 0, then it is a possible and irreversible engine. And if the cyclic integral del q by t that is equal to 0, then it is a possible and reversible engine. And if the cyclic integral of del q by t greater than 0, then it is an impossible engine. Okay, now so consider there is a question. So understand this question carefully. So there is a three reservoir, that is one reservoir which have temperature 1000 Kelvin, and another reservoir which has temperature 500 Kelvin, and there is another reservoir that is temperature 300 Kelvin. So in between three temperature there is an engine is there. This engine basically absorb that 100 kilojoule of heat from 1000 Kelvin temperature reservoir, and absorb 50 kilojoule of heat from 500 Kelvin temperature reservoir, and reject 60 kilojoule of heat to the 300 Kelvin temperature reservoir. And there is a work which is produced from this engine that is equal to 90 kilojoule of work. So you have to prove that this is a reversible engine or irreversible engine or impossible engine. You have to prove that the question is that is this engine is possible or reversible or irreversible. You have to prove this. Okay, so the answer will be focus on the answer. So here this is the answer here. So cyclic integral of del q by t that is equal to 0, that is equal to we have to consider that. So cyclic integral of del q by 2 we have to derive. Okay, cyclic integral of del q by t. So here the remember this here 100 kilojoule of heat is rejected. So 100 kilojoule of heat is going into the system. Okay, so that is why positive plus 100 q by t plus of 100 by 1000. Okay, from where the heat is coming. Okay, so 100 divided by 1000. So from here you can say that plus the positive sign because heat is going into the system. So that is why there is a positive sign, positive of 100 divided by 1000. 100 that is amount of heat, that is 100 kilojoule, by the amount of temperature, the reservoir temperature, that is 1000. Okay, in the same way, there is a 50 kilojoule of heat which is going into the system from 500 Kelvin reservoir. So that is why positive value. There is a positive because this is the heat is going into the system. Okay, so 50 the amount of heat which is absorbed by the system from 500 Kelvin temperature reservoir. Okay, and in the same way the 60 kilojoule of heat is rejected to the from this system. Okay, to the reservoir. So that is why there is a negative sign because heat is rejected. So minus of 60 by the amount of reservoir temperature. So this is 300. So from here you can get the value that is 0. So if it is 0, in Clausius inequality it say that if it is 0, then it is a possible and reversible cycle, reversible engine. So from here you can say that this is a reversible heat engine. Okay, this is a reversible heat engine. So okay, so this is very easy question. In the same way you can understand, try to understand this question. Okay, so try to understand this question. So read this question carefully. Same question. So here what is given? A heat engine operates between three reservoir R1 at 550 Kelvin, R2 at 450 Kelvin, and R3 at 350 Kelvin. Okay, for every cycle the engine accept 100 kilojoule from R1 and reject 60 kilojoule in R2 and 30 kilojoule into R3. Okay, so the engine efficiency, you have to calculate the engine efficiency. So what is the answer? So here, this is the answer here. There is a in that question there is a three reservoir, that is R1, R2 and R3. So here this R1, there is R1 reservoir, and this R1 has the reservoir temperature 550 Kelvin, and R2, there is a R2 reservoir that is 450 Kelvin, and R3 reservoir, so there is a 350 Kelvin. So draw this reservoir. So this is R1 reservoir, this is R2 reservoir, and this is R3 reservoir. Okay, so in between there is a heat engine is there. So heat engine basically absorb, that is 100 kilojoule of heat from this reservoir, and it is basically rejected 60 kilojoule of heat to this reservoir, R2 reservoir, and reject 30 kilojoule of heat in that reservoir. So this is 350 Kelvin. Okay, now you have to derive the efficiency of the efficiency of this engine. Now if you calculate this cyclic integral of del q by t, so here 100 kilojoule of heat is going into the system, so plus 100 by the temperature, that is 550. So here this temperature, okay, this temperature, minus 60. So here heat is going from this system, this is the system hour. So here 60 kilojoule of heat is going from the system, so that is why there is a negative sign. Okay, 60 divided by 450, 450 is the source temperature, this is the reservoir temperature, and there is 30 kilojoule of heat which is going from the system, so that is why there is the negative sign by 350. Okay, so this value, probably this value is negative value, and this probably you can calculate this value 0.01 something, you can calculate this value. So there is a negative value, and if there is a negative value, you can say that this is an irreversible engine. Okay, this is an irreversible engine. Now this is an irreversible engine. Now focus on that. Here focus on this system. So focus on this system here, this system. There is a 100 kilojoule of heat is going into the system, and 60 kilojoule of heat going out from the system, and 30 kilojoule of heat is going out from the system. So from the first law of thermodynamics, you can say that from first law of thermodynamics, the 100 kilojoule of heat is going into the system. Okay, so suppose consider there is a W amount of work, that is output is W. Okay, so if you apply the first law of thermodynamics, so here 100 kilojoule of heat is going into the system. Okay, so plus 100 or you can say that 100 amount of heat is going into the system, so 100, and that is equal to 60 kilojoule of heat is going out from the system. So you can say that in that way, so 100 kilojoule of heat is going into the system, minus 60 kilojoule of heat going out from the system. There is a work going out from the system, and there is a 30 kilojoule of heat which is going out from the system. So from here you can get W that is equal to 10 kilojoule. Okay, so 10 kilojoule. So from here if you want to calculate the efficiency, that is basically output by input. So efficiency W, what is the output? That is W, that is 10 is the output, and there is a 10 is the output, and what is the input? So in this engine there is an input, that is 100 kilojoule. Okay, that means 100 kilojoule of heat which is going into the system. So this is our input. So here this is 100. So if you calculate this value will be 0.1. Okay, so the efficiency will be 0.1, and if you multiply it by 100, 100, this will be 10%. Okay, so in percentage the answer will be 10%. Okay, so this is our answer. Okay, in the same way, you can try another question, same question, just different data is given. So here try to understand this question, so figure show a system undergoing a reversible cycle. So this figure is given, okay, so during which it exchanges heat with 3 thermal reservoir and develops 1000 kilojoule of work. So there is a 1000 kilojoule of work is produced by this heat engine. So find the magnitude and direction of QB and QC. So in this diagram, so basically there is a reservoir which has had 1000 Kelvin temperature. There is another reservoir B which is have 300 Kelvin temperature, and another reservoir C which is 500 Kelvin temperature. Now basically here 5000 kilojoule of heat which is going into the heat engine from reservoir A reservoir, and there is a work that is 1000 kilojoule of work produced, and there is a QB and QC is there, but their direction is not there. Okay, so you have to find out the direction. In that question, find the magnitude and direction. So you have to find out the magnitude and direction of QB and QC. So their direction is not given, so their direction may be this or this, here direction may be this or this. So their direction is not given. You have to uh, uh, you have to find out the direction as well as the value, the magnitude of QB and QC. So this is all about the question. Now so here so first consider the heat is going out from the system. QB amount of heat is going out from the system. System means this is our system here. So QC amount of heat which is going out from the system and going to 500 Kelvin temperature reservoir. Okay, so if you apply the first law of thermodynamics, so here if you apply the first law of thermodynamics in this heat engine, so basically here 500 kilojoule of heat is going into the system, so that is equal to 5000, that is equal to W. W is going out from the system, so equal to W plus QB plus QC, because QB and QC is going out from the system. So 5000, that is equal to W plus QB plus QC. So this is equation number 1. Okay, now from second law, so here what is given from second law, you know that is del Q by T, that is equal to 0. Okay, so del Q by T means del Q, that is a 5000 kilojoule of heat which is going out from the system. Here that is 5000 kilojoule of heat is going out from the so going into the system, so that is a positive value. So positive plus by 1000 minus QB by 300, because QB amount of heat is going out from the system. Okay, and minus of QC by 500, 500, so that is equal to 0. So here from equation number 1 and 2, so here W is equal to 1000. So here 500 in that equation, 5000, that is equal to 1000 plus QB plus QC. Okay, QC. So from here you can say that QB plus QC, that is equal to 4000. Okay, so this is equation number 1. Okay, and this is equation number 2. So from equation number 1 and equation number 2, you can get QB that is equal to minus of 2250 kilojoule and QC that is plus of 4250 kilojoule. So here this minus sign indicates that the sign will be in opposite direction. So here QB is negative sign, that indicates that the QB sign will be in opposite direction. So actually the QB sign in this direction, okay, in this direction. So previous direction is not correct. So in this direction, and this is the same direction, okay, because there is a positive value QB, and the magnitude is also determined. Okay, now if you want to calculate the efficiency, so efficiency is basically output by input. So efficiency, that is eta, that is equal to output. So here output is 1000, 1000. So here this is the output here, that is the output, that is 1000 kilojoule. And what is the input? So here this is 5000 kilojoule of heat which is input, and QB is also going into the system, this will be input. So these two will be total input. So here if you want to calculate the efficiency, that is output, that is 1000 divided by 5000 plus QB is 2250. So from here you can get the efficiency, okay, you can get this efficiency. Okay, so this is all about the Clausius inequality problem. Now there is another problem, you can do this, there is another problem and this is the answer, and there is also another problem and there is answer. Okay, so this is all about the Clausius inequality. This is my handwritten notes, you can download it from the description link. Like, share and subscribe my YouTube channel. Thank you.